Okay, chapter 9, aldehydes and ketones. Introduction. Aldehydes and ketones are organic compounds responsible for the taste and aroma of many foods used in our everyday life, such as vanilla, vanillin for vanilla taste, cinnamon aldehyde for cinnamon, benzaldehyde for bitter almond, for ketones, carbon for caraway, jasmine for jasmine, 2-heptanone for blue cheese. Now definition, what is an aldehyde and ketone? Aldehydes and ketones are organic compounds that contain the carbonyl group C double bond O or CO as the only functional group. Aldehydes are organic compounds that contain the carbonyl group connected at least to one hydrogen atom. The general formula of aldehyde is RC double bond O single bond H. The functional carbon C double bond O is connected to one hydrogen atom. C double bond O is connected to one hydrogen atom. This is the general formula of an aldehyde. Ketones are organic compounds which contain the carbonyl group, a carbonyl group connected to two alkyl groups, and the carbonyl group is not hydrogenated. The C double bond O is not connected to hydrogen atom. The general formula is RCOR prime or RC C double bond O R prime. The carbonyl group C double bond O is connected to alkyl group, and another alkyl group is not connected to hydrogen atoms. Now, general molecular formula. We take an example, ethanol of formula CH3CHO is an example of a saturated, has no double bond between carbon atoms, and open chain, has no cycle in its carbon chain. This organic compound, its molecular formula is C2H4O. In general, number of carbon in organic is represented by N, and number of hydrogen by 2N, and other number plus 1, plus 2, minus 1, minus 2, or without adding or subtracting any number. This molecular formula is 2H4O satisfies the general formula CnH1. Then CnH2n in general. N in this case equal 2. 2 times 2 equal 4, and we have number of hydrogen equal 4. Then we don't need to add any number. Then and we add O. Then the general molecular formula of this aldehyde, of aldehydes in general, CnH2nO. Which aldehyde? Open chain and saturated. For ketones, also we take an example, propanone for example, CH3COCH3 is an example of open chain saturated ketone. Its molecular formula C123 C3, 6 hydrogen and 1 oxygen, C3H6O. Also number of carbon represented by N in general, and hydrogen 2N and what another number. In this case, N equals 3, then 2N equal 6. Then we don't need to add any number. Then the general formula of ketones is CnH2nO. Also we, as we said, open chain and saturated ketones. Therefore, the general molecular formula of a saturated non-cyclic or open chain aldehydes or ketones is CnH2nO. Then aldehydes and ketones are isomers because they have the same molecular formula. What is the need of this general molecular formula? if we are given the percentage by mass of any element, carbon or hydrogen or oxygen, we can determine its molecular formula by determining N. How? First, we calculate the molar mass in terms of N. The molar mass of carbon 12 times the number of carbon N, 12N. Number of hydrogen 2N, the mass of hydrogen 1 to N. Oxygen, number of oxygen atoms is 1, and the molar mass of oxygen 16. Then the molar mass of aldehyde or ketone is 14N plus 16 gram per mole in terms of N. Now, if we are given the percentage by mass of any element of the aldehyde or the ketone, we can determine its molecular formula based on the relation percentage by mass of carbon over 12N equal percentage hydrogen over 2N equal percentage oxygen over 16 equal 100 over molar mass, which is 14N plus 16. If we are given percentage by mass of carbon, we take the percentage of carbon with 100 over molar mass, then we calculate N. If we are given the percentage by mass of hydrogen, the same, we take the percentage by mass of hydrogen over 2N with 100 over 14N plus 16, and the same for oxygen. Okay. Now, if we are given the percentage by atoms or by moles of any element, the relation becomes percentage carbon over N. N is the number of carbon atoms, equal percentage hydrogen over 2N. 2N is the number of hydrogen atoms, equal percentage oxygen over 1. 1 is the number of oxygen atoms, equal 100 over 3N plus 1. Nomenclature. Naming of aldehydes and ketones. First, for aldehydes. According to IUPAC rules, the systematic name of an aldehyde is derived from the name of the alkane having the same number of carbon atoms in the main chain. But we replace the final A by al. For example, in general, alkane, we replace E by al, the name becomes alkanal. Examples: first aldehyde formed of one carbon, alkane of one carbon is called methane. We add al, replace E by al, then the name becomes methanol. Another example: second aldehyde formed of two carbon, alkane of two carbon ethane plus al, ethanol. 3 carbon, propane, propanol. C6H5CHO or cycle C, this is the C6H5, C double bond OH. Now derived from the non-systematic name of C6H6, which is benzene, we add aldehyde, benzaldehyde, or phenylmethanol. When C6H5 is considered as an alkyl group, its name becomes phenyl, and aldehyde formed of one carbon is methanol, then the name becomes phenylmethanol. In case of branched aldehydes, the functional carbon, the carbon holding the functional group C double bond O, is always considered as the number 1, carbon number 1. For example, CH3, CH, CH3, CH2, C double bond OH. We should determine the main chain main chain is formed of 4 carbon, and CH3 is the alkyl group. The alkane formed of 4 carbon butane, we add albutanol, and we have CH3 metal on carbon 1, 2, 3, 3 methyl butanol. Carbon number 1 is the functional carbon. Its name becomes 3-methyl butanol. Another example, the main chain is formed of 5 carbon, 1, 2, 3, 4, 5, and we have ethyl and methyl as alkyl group. The main chain 5 carbon pentanol, we have ethyl on carbon 1, 2, 3, and methyl on carbon 4, ethyl before methyl, alphabetic order, E before M, then its name becomes 3-ethyl 4-methyl pentanol. The name is 3-ethyl 4-methyl pentanol. Okay. Next, for ketones. According to Iopakos, systematic name of ketones is derived also from the name of the alkane having the same number of carbon atoms in the main chain, but by replacing the final E by the ending on. Alkane, we replace E by on, becomes alkanone, is the general name of alkane. Example, CH3, C double bond O, CH3 is the first ketone formed of 3 carbon. We have no ketones formed of 2 carbon or 1 carbon because the functional carbon should be connected to alkyl group, at least 1 carbon from this side and 1 carbon from the other side. Then the first ketone is formed of 3 carbon atoms. Its name is propanone, propane 3 carbon, we add on propanone. 4 carbon, butanone. For n bigger than 4, for 5 and more, the functional carbon may have different positions. Then the carbon atom of the main chain are numbered such that the position of the C double bond O group is given the lowest possible number. Example, CH3, CH2, CH2, CO, CH3. From this direction, carbon C double bond O takes the position 1, 2, 3, 4, while from the other side direction, carbon of C double bond O takes the position number 2. The lowest number is for this direction, this the direction, the correct direction. Then 1, 2, 3, 4, 5 pentanone, and on the carbon number 2, then its name becomes 2-pentanone. Another example, from the two sides the same number 3, 1, 2, 3, 1, 2, 3, then its name is 3-pentanone. In branched ketones, the carbon atom of the carbonyl group takes the lowest number in preference over all alkyl groups. Example, in this example, in this direction, C double bond O takes the number 1, 2, 3, 4, 5. In this direction, number 2. Then this the correct direction. Then its name 1, 2, 3, 4, 5, 6 hexanon, and on carbon 2 hexanon, and we have CH3 methyl on carbon 1 2 3 4, then it's named 4 methyl 2 hexanon. 4 methyl 2 hexanon. Next, isomerism. Aldehydes and ketones are functional isomers. They have the same molecular formula but different structural formula and different function. C4H8O, for example, has 3 isomers, 2 aldehydes and 1 ketone. First aldehyde, butanal. Second aldehyde, branched aldehyde, 2 methyl propanal, and 1 ketone, butanol.